So this is the last type of factoring we're going to look at. Tomorrow and Thursday we're going to kind of review all of it. I'm going to give you kind of a map so you can kind of, so it's easy for you to kind of decide which way to solve. So I'm going to kind of give you a map that allows you to kind of go through the steps and kind of help you figure out which ways to solve. So if I look at 8, we are looking at the difference of squares. This is how we factor the difference of squares. So, put your phone away, please. Phone away. In your pocket. I'm tired of having phones out. I've already said it twice to people today. So phones in your pocket. If I see it out, they're going on my desk the rest of the block. Because people haven't been able to handle their phones with them, they're going to be put in your lockers next year. So, that is the plan. Don't want to see phones out. So, as I look at 8, it is the difference of squares. Think about what that means. Difference means what? Subtraction. So we have to be subtracting. So if I look at difference, I have to be subtracting things. That's what difference means. And if I look at the word squares, we're looking for perfect squares. Sorry. Gross. I mean this. I got that all on video. I hope someone watches that too. I'm draining, so I coughed and a big chunk of mucus came out. I know, that's why I try to be discreet about it, but it's hard to and I can't talk. Anyway. I know. Have fun, who's ever watching this. I'm coughing in the face. Okay, anyway, so difference of squares. Difference we're subtracting. Squares we're looking for perfect squares. You know what perfect squares are. 4, 9, 16, 25, 36, blah, blah, blah. That's what we're looking for. So we're looking for difference, subtraction, perfect squares. Now, you are going to use this when you have a binomial. So as you look at how many terms you have, we did trinomials the past week. Whether the coefficient was 1 or the leading coefficient was 1 or not, we were still dealing with trinomials. Today, this is how we're going to start trying to factor binomials, by looking for a difference of perfect squares. A couple steps. First step, always factor out the GCF first. That is for any factoring. Anytime it says factor, always look for a GCF, and we're going to talk more about it tomorrow. We haven't really had a ton of GCFs. The homework I gave you tomorrow, you're going to have more GCFs you have to factor out first. Step 2, write each term as something squared. Not going to make a lot of sense, but as we look at it, we are going to look at my terms and we are going to rewrite it as something squared. And this is why we did the warm-up. So you can see, okay, what squared gives me 9? What squared gives me 16? What squared gives me 9t squared, whatever. So we're going to rewrite each term as something squared, and you're going to have something like this. Something squared minus something squared. A squared minus b squared is how you'd see it written in most textbooks. Something squared minus something squared. Now your final answer is going to be written as a plus b and a minus b. And from the step right before it, this was the step right before it, I'll write it up here. What do a and b mean? A is whatever you wrote as the first term. So if I look at my first term and I said to get the first term, I can do a squared, something squared. So a is the first thing in parentheses and b is the second thing in parentheses. That's it. So don't get confused with the a and b. All a and b represent. A is the first thing that was being squared, and b is the second thing that is being squared. And you add them and subtract them, and that's it. So, going to take a little bit of getting used to, but once you get through it, it's a lot less work than what we did last Thursday. You don't have 5 different steps to do. You don't have to do GCF and grouping and multiply to get this and add to get this. So it's a little more straightforward than what we did Thursday. So let's go ahead and look at example 1. Let's look at A. So as I look at A, first of all, I noticed I have a binomial. If you have a binomial, this is the first thing you think of. The only way we're going to talk about in this class how to factor. So if I have a binomial, First thing I want to look for is a GCF. Do I have a GCF between 16h squared minus 9a squared? Do 16 and 9 have a GCF besides 1? No. Do these share variables? No. So there's no GCF. So now I want to look and say, okay, it is a binomial. It's subtraction, so I have the difference part taken care of. Can I write each term as something squared? Is each term a perfect square? Because it has to be a difference, has to be subtraction, two things squared. So let's think about it. So this is step 2, right? Each term is something squared. It has to be subtraction. If you have a plus, then you can't go any further. It's prime. Prime is what you write down if you can't factor it. So if it's plus, two things added together, it's prime. You can't go any further unless there's a GCF. So let's go ahead and look at each term. What squared gives me 16h squared? So first of all, let's look at 16. What squared gives me 16? 4. What squared gives me h squared? H. So that's what you're going to go. You're going to go through each term and try to write it as something squared. What squared gives me each term? Next one. What squared gives me 9a squared? 3a. So that's it. You're going to go through each term and you're going to try to figure out what squared gives you each term. Now this is your a. Whatever's in the first parenthesis, that's really bright. Whatever in your first parenthesis is considered your a. Whatever's in your second parenthesis is considered your b. So when you go back and look at it through the steps and you see a minus b, a plus b, that's all I refer to. What's in the first parenthesis is a, what's in the second parenthesis is b. So to write your final answer, all you do is you take your first thing in parentheses, a plus b. So you take your first thing plus b, which is your second thing. So 4h plus 3a. So the first thing in parentheses plus the second thing that's in your parentheses. Your next parenthesis looks like the first thing, which is your a part, 4h minus your second thing, 3a. Huh? They will when I check it. They'll cancel out. And we'll go to check it in a second. Is this factored? Yes. Why? Something times something. That's what factored means. So it's factored. So let's go ahead and check it real quick. Let's just check and see if I get back to the original. So if I check this, how will I multiply this? Using what? It's a binomial times a binomial. So I'm going to use FOIL. Or just think distributing. If FOIL will confuse you. 4h times 4h is what? 16h squared. When I multiply my outside 2, 4h times negative 3a. Negative 4h times negative 3a. AH. Negative 12AH. Your inside 2, 3a times 4h. Positive 12AH. And then 3a, by last 2, 3a times negative 3a. Negative 9a squared. No, I'm just doing it to check it. Yep. I'm just showing you like I did on the other ones. You can always check it by foiling it. Now, like Jake said earlier, my middle two terms are going to cancel. So I have 16h squared minus 9ah. 16h squared minus 9a squared, which is the original. So that is correct. You can always FOIL through to check your answer. So I'm not going to show it with you. Your homework says to check it. I'm not going to make you check it, but you always can. So I at least want to show you that you can check it. Okay, any questions so far? Okay, let's look at B. First thing I notice is it is a binomial. We're going to be talking about it more tomorrow. You want to look at how many terms it has. It's a binomial. Is there a GCF between 81 and x squared? No GCF. So I notice it's a binomial. There's no GCF. So my first thought is the difference of perfect squares. Can I use that factoring method? First of all, is it a difference? Yes, there's subtraction. That is not hard to see if it's a difference. If I'm subtracting two things, it is a difference. Perfect square is a little trickier, not necessarily for this one. You want to think to yourself, can I write each term as something squared? And I like actually doing this step because, especially when it gets a little trickier, it's easier to see what's your A part and what's your B part. So let's go through each term. What squared gives me 81? 9. What squared gives me x squared? X. This is not factored because I have a big minus in the middle. Factoring is something times something. So this is not factored. Even though you see parentheses, there's a big minus in the middle. So to write my final answer, it's going to look like nine plus x and 9 minus x. Does the order matter? No, multiplication order does not matter. So you could have 9 minus x times 9 plus x. That was a more straightforward one. Okay, questions so far? A lot less work than what we did last Thursday. Okay, let's look at C real quick. So if I look at C, first thing I always want to look for whenever you're factoring is a GCF. Is there a GCF for 27g cubed minus 3g? 3g. So I'm going to take a 3g and I'm going to factor it out first. So we're going to take a 3g and factor it out first. You always look for GCF first, and we're going to talk more about it tomorrow. We haven't done a ton of work with factoring out a GCF and then going further. We're going to do more with it tomorrow. So I take out a G3, that's funny, G3G, 3G. So I take out a 3G, let's see what's left. 3 times what gives me 27? 9. I started with G cubed, and I took out G to the first. So I have G to the what left? G squared. 3G times what gives me negative 3G? So negative 1. So 3G times the negative 1 gives me a negative 3G. So I took out a GCF. We've done that for a while. Now you always want to check in your parentheses and see if I can take it one step further. Your 3G is just going to hang out there. Once you take out a GCF, you forget about it. I feel like, what if you might be too young for this? There's one where they're like, just forget about it. Like, set it and forget. I don't know. You're too young. Anyway, I digress. But just take it out front and forget about it. Don't worry about it. It's out there. You took out the GCF. Don't worry about it. Look inside your... So I want to think to myself,
is it a difference of perfect squares? So as I'm just going to kind of do it to the side here. Obviously it's a difference because I'm subtracting. Can I write each term as something squared? So that's what we're going to look at.
Pardon the interruption. At this time, the boys soccer team needs to be released to go to the TV studio for a few minutes. Again, boys soccer team, please go to the TV studio for a few minutes.
Okay, so as I look at this, I want to think to myself, what squared the difference of perfect squares? Hunter, put that away. Nice try, you did it for a while before I taught you. So what squared gives me 9g squared? What squared gives me 1? If you can't think of something, then you can't factor it like this. But most of what you're going to be working with, you're going to be able to write it like this. So what squared gives me 3g squared? Or 9g squared? 3g. And what squared gives me 1? 1. So 2 terms. This is how we want to try to factor it, at least in Algebra 1. So now that I was able to write it as a difference of perfect squares, how do I write my final factor form? (3g plus 1) and 3g minus 1. And that is the final factor form, because it is something 3g times 3g plus 1 times 3g minus 1. So that is your final factor form. Okay, we're going to skip D for right now. Any questions so far? Okay, let's look at E. So rewrite E to what I have written there. 2b to the 6th minus 32b to the 2nd. So rewrite e real quick. 2b to the 6th minus 32b to the 2nd. Whenever you are factoring, you always want to look for the GCF first. So what is the GCF of, or is there a GCF of 2b to the 6th minus 32b to the 2nd? 2b to the 2nd. So I look for my GCF, and it is 2, because the biggest number that goes into 2 and 32 is 2. And then they both share b, you pick the lowest exponent, so that's b to the 2nd. So now I go through and I want to see what's left. So if I take out a 2b to the 6th, or sorry, if I started with 2b to the 6th and I took out 2b squared, I'm going to have what left? b to the 4th. Good. So I'm going to have b to the 4th. Now let's think. 2 times what gives me negative 32? Negative 16. Do I need any b with it? No, because I started with b squared and I took out b squared. So now it's b to the 4th minus 16. So my 2b squared stays there. My GCF stays there. So I need to look in my parenthesis part and say, can I factor it further? What do I notice about the part in the parenthesis? As I'm trying to look and see if I can factor the part in the parenthesis more. What did you say? Sorry.
Nothing can equal b squared. B to the second.
Well, I think you're starting the right track. I see 2 terms. So my first thought is difference of perfect squares. Do I have a difference?
Yeah.
Yes, I have subtraction. That's the first thing. If you don't have a difference, if you're not subtracting, you can't do it. I have a difference. Can I write each term as something squared, which is what I think you were trying to get to? So can I write each term, since it's 2 terms and there is a difference, can I write them, are they perfect squares? Can I write them as something squared? So what squared will give me b to the 4th? B to the 2nd. Like we did on the warm-ups, you multiply your exponents. So what squared gives me b to the 4th? B to the 2nd. What squared gives me 16? 4. So rewrite it like this, because it helps you see what your a and b values are. It helps you see what your first part is and what your second part is. So as I write my final answer, what will my final answer look like?
B squared plus 4.
Yep. B squared minus 4. Like I said, it's a lot less work than what we did last Thursday, but you kind of have to think about what squared gives me this, what squared gives me this. And that's my final answer, because it is 2b squared times b squared plus 4 times b squared minus 4. Now, let's keep looking. I didn't expect this. Can I factor this further? Look at your part. Can I factor 2b squared any further? No, it's a monomial. B squared plus 4. I have 2 terms. I notice these are kind of perfect squares. Can I factor b squared plus 4 further? Can I use difference of perfect squares to factor b squared plus 4 further? Can I use difference of perfect squares to factor b squared plus 4 further? No, why not? Do I? Think about it. You're overthinking this. B squared plus 4. I know b squared and 4 are perfect squares. Can I use the difference of perfect squares to factor b squared plus 4? You're overthinking this. Listen to what I'm saying. Can I use the difference of perfect square strategy to factor b squared plus 4? Yes, no, you cannot. There is plus. Do not overthink it. Even if you have 2 terms, and even if they're both perfect squares, if it is not a difference, you cannot use this strategy. You have to be subtracting. So I cannot take b squared plus 4 any further. So now I look at my next one. I didn't expect this. You can use this space down here. We're not going to do example 4 on here, so you can use that space. Now I look at b squared minus 4. There are 2 terms. It's a binomial. Is it a difference? Yes. So can I factor that part further? So far, I have 2b squared. I have b squared plus 4. I couldn't factor that any further because it was a plus. But I noticed my last parenthesis was b squared minus 4. So I think to myself, is that last parenthesis a difference? It's minus, so we're good with that. Can I write each term as something squared? So what squared gives me b squared? B. And what squared gives me 4? 2. So my last parenthesis I can factor again. And we're going to talk more about this tomorrow. I didn't really expect to go further, but we can. It's the same idea. So now, the first two parts I'm not worried about. The 2b squared and the b squared plus 4 are just hanging out there. This b squared minus 4, I factored as b squared minus 2 squared. So now how do I write the final answer for the b squared minus 4? And what? b minus 2. That comes from this part. So that is my final factored form. So that, like I didn't expect to go through this today, so it's not going to hurt you. I don't think there's any other homework tonight where you have to do multiple factoring. Tomorrow there will be. So you always have to look and say, can I factor any part again?
Homework tomorrow too.
Yeah, it's going to be the big review packet, so you have multiple days to do it. Okay, let's look at one more real quick. Let's look at F, and we'll be done today. You have a good chunk of time for homework, so you should be able to get most of it done. It shouldn't take too long, which is what I wanted.
This is probably one question.
No, you're fine.
Wouldn't those guys be the same? Like,
What?
on E, instead of having b, 2b squared plus, b squared plus 4 and b squared plus 2, b squared minus 4, 2.
These two right here,
Yeah, shouldn't those two parentheses be the same as the first one?
as up here, b squared minus 4. Is that what you're asking?
Yeah, shouldn't those two be the same?
They are the same. If you had foiled through, they would give you b squared minus 4.
I just got completely lost.
That's fine. This b squared minus 4 we factored again like we did because it was a difference of perfect squares. So we could factor it as a b plus 2 and a b minus 2. So we just took it again. Don't worry too much if that makes, we're going to explain it more tomorrow, but I don't think there's any other homework like that. So
Probably just overthinking.
I think you are, but that's okay. We'll get to more like that tomorrow. For today's homework, you don't have to go that far, I'm pretty sure. Okay, let's look at F. So 2 terms. So my first thought, this is the last example we'll do, we'll be done. So 2 terms. Whenever I'm thinking 2 terms, we always want to think a difference of perfect squares. Can I use that strategy? Difference of perfect squares. First of all, is it a difference for F?
Yeah.
Yes, I am subtracting. That is not hard to figure out. If you're adding 2 things, you cannot do it. It is prime and that's it. Prime means you can't factor it. It is a difference. Can I write each term as something squared? So let's think. So 2, I like doing this step, so it helps me figure out what my final answer looks like. So what squared, don't blurt it out, what squared gives me 625? Use a calculator if you don't know. Let's think about it. And what squared gives me, look at your last 2 digits. My last 2 digits are 25. So in your mind, if my last 2 digits of 625 are 25, what am I thinking my last digit will probably be? A little more specific. If I'm trying to square something to get 625 and my last 2 numbers are 25, my last one will probably be 5. So that at least gives you kind of a hint, because I know 5 squared gives you 625. So what squared gives me 625? Someone who has a calculator. 25. I believe it's 25. So 25 squared. So you just have to go through. Yeah, 625. If it's a big number like this, you just have to go through your calculator and start squaring things. Now, what squared gives me x to the 4th? X squared. So now let's go through and see what I have. Final answer?
25 plus x squared.
25 plus x squared and 25 minus x squared. Now this might answer your question, Jake, because we're going to have to do it again. As I look at this, I need to ask myself, is this factored completely? Look at each parenthesis. 25 plus x squared. Can I factor 25 plus x squared again. No, why not? Because it is a plus. It is not a difference. It is a plus, so I cannot factor that anymore. So I'm just going to write it right underneath it. Then I'm going to look at my next one. I see a binomial. I see two terms. I see 25 and x squared. So in the back of my mind, I think those are perfect squares. Can I use the difference of perfect squares to factor 25 minus x squared?
Yes.
Yes, because it is subtraction. So let's go through real quick. We can do it again. I'm going to do the workout here on the side. Can I write each term as something squared? This is a little easier to see. What squared? I'm only worried about my last parenthesis. What squared gives me 25? 5. And what squared gives me x squared? X. So now my last parenthesis I can split up as
5 plus x.
and what?
5 minus x.
5 minus x. Now that is my final answer. So you always want to look, and you're going to do it more on the packet I give you tomorrow. Can you take it one step further?
What's our test?
Next Tuesday. Okay. Any questions so far? Okay, that is the homework. Let me give you those are the notes.
The homework, I'll find out.